Hi there and welcome back to the M5 Stack official channel. I'm Luke, and in this video we're going to be looking at how to add a display to the M5Atom. Whether it be the M5Atom Lite or M5Atom Matrix with its LED display, some users on Twitter and forums have suggested that it's a little bit difficult to display data with these devices, and they wish that it had a screen. There's a lot of these nice monochrome OLED displays out there for quite cheap, and they're not too much bigger than the M5Atom itself. I've seen plenty of guides on this on how to program this device with Arduino, but I didn't really see any of these guides on how to use Micropython. So in today's video we're going to be looking at how to use Micropython to program this display to display information from the M5Atom. Let's get started. Let's have a look at the OLED that we'll need for this project. These OLEDs come in various shapes and sizes, but they all use the same driver chip, which is SSD1306. So a quick search for this chip name will come up with a whole bunch of compatible screens that we can use. Make sure though that you get the I2C version, which should have a 4-pin connector of some sort on it. The one that I'll be using in particular for this video is by YWrobot, and I'll leave the link for this product down in the description. The reason why I like this particular model is that it has 4 screw mounting holes and also has a connector which we can adapt a growth cable to fit. It also comes with a cable which ends in a Molex connector, so you can connect it to the back pins of the Atom with jumper leads if you so wish. The connector looks almost identical to Grove, but let's compare them side by side. You can see here that the XH connector of the YWrobot module looks almost identical to the Grove or HY connector that we use on most M5 Stack modules. The only difference being that there are 2 channels at the side for the plastic nibs to go into. We can easily modify a growth cable, however, by simply taking a knife and slicing the 2 plastic nibs off of each side. Now it fits quite snugly into the slot. So let's connect the other end up to the M5Atom. Note that if you use the base of the M5Atom to connect, make sure that you connect the SCL pin to pin 21 and the SDA pin to pin 25. We'll be using the Mu editor for this tutorial. Make sure if you haven't followed any of our M5Atom in Mu IDE tutorials before that you make the changes in the config file. You can see how to do so in this previous video. It doesn't matter if you're using the UI Flow firmware or the official Micropython firmware. Just make sure that we'll need to add the SSD1306 library to the flash of the device. I'll be placing the GitHub link to the SSD1306 module in the description. Make sure to put it in your Mu code folder if you're using Mu to transfer the files across. Once that's copied successfully, first we'll go ahead and set up the I2C interface. We'll need to make sure that the device is being recognized. So first from machine we'll import both I2C and also the pin functions. Then we can set up an I2C object and the SCL pins. If you're using the growth cable is pin 32 for SCL and pin 26 for SDA. Now that we've set that up, we can do a quick scan with I2C.scan and we should get 60. I2C scan always returns the address in decimal, so this would be 0x3c in hex, which is as the manufacturer stated. If you get a different number, don't worry, your I2C address might be different for your device. As long as it has the SSD1306 chip, you should have no problems. So let's go ahead and copy across all of those lines to start to build our script up. And as I said earlier, if you wish to use the bottom pins, that would be SCL21 and SDA25. I'll also be uploading this script to the GitHub, so you can just uncomment this if you wish to use either or. Okay, now let's go ahead and import the SSD1306 module, and we'll set it up with OLED equals SSD1306, same again in capitals, but then with I2C, maybe your device's SPI. I can't help you there, we're just focusing on I2C in this video. And then we need to pass as the arguments the width and height of the screen, and then the I2C object. So as we saw earlier on the Amazon page, these displays come in a lot of different form factors. My particular one is 128 by 32. Yours might be different, so you might need a little bit of trial and error here. And once we've done that, we can do a quick test by using the OLED.text function, passing hello world, then followed by the XY coordinates, and 0 or 1. 1 will be white, 0 will be black. So nothing will display obviously if we have a black background. And it won't show up immediately on the screen, as we have to also use the OLED.show function. And there we have it, hello world on the screen. Now let's go ahead and copy all of those necessary lines from the REPL into our script. And next we're going to be doing something a little bit more useful when printing hello world. So we shall import the IMU. So we're going to try and get to show some gyro readings on the screen. So we'll instantiate this object IMU0, and I'm going to create the variable data to store the acceleration data from the IMU. And if we do a quick print, then we can see that the data from that is the X, Y, and Z acceleration. And of course we'll need it to be in a loop if we want to see the acceleration values constantly updating. So I'll go ahead and copy those lines from the REPL again, and then make sure we have a while loop set up, and then I'll enter the data variable into the OLED.text function. Okay, now if I go ahead and do this now, I'll just have a bit of a garble on the screen, because what it will do is basically print the values over the top of one another. Or no, it won't, because I need to convert it to a string first. So I'll go in there and make sure this value is set to a string. So regardless of whether it's a string or not, the values will be written over the top of each other. Now with this OLED module, there is no clear screen function. So what we actually need to do is fill the screen with black, and then provide a little bit of a delay, and then write the values again over the top. So in order to do that, we'll require the time module. So we'll go ahead and import time, and then add the line time sleep milliseconds, and then finally at the end we add OLED.fill 0 to clear the screen. And now we see that we are getting that XYZ value, but it's not showing because I need to put this variable here inside the loop, of course, so that it's constantly updated. Okay, and then we'll go ahead and try that. And now we can see the values changing if I give the atom a bit of a shake, and we can see the acceleration values changing. Okay, I'm going to go ahead and save that now. What I'm going to do now is to show you some various ways to create graphics on the screen. I found this particularly nice article here from 2-Bit Arcade, which nicely documents this SSD1306 library. See here we can do various things such as to set pixels on the screen, draw some primitives such as vertical, horizontal, diagonal lines, rectangles, filled rectangles, etc. But the thing I liked most about this tutorial was how it showed you how to make your own custom graphics from arrays. So we copy and paste that over, just change out these displays to OLED as I've set it in mine. Now if we go ahead and run that, we can see this nice little heart on the screen, and a little bit further down in the tutorial we can also see how to copy those glyphs around randomly across the screen. Try that out. And there we go. Doesn't that look fantastic? There are various other commands that we have in the OLED library, and such as being able to invert the screen. So just type OLED.invert, and then number 1 if we want the background to be white. And we can see now that our image is flipped. So lots of nice ways we can create text and graphics on an OLED screen with the M5Atom. That's about all we have time for in this week's video. I'd like to hear what kind of projects you would like to make if you use an OLED screen with your M5Atom devices. Make sure to leave that down in the comments. As always, don't forget to like, subscribe, and I'll see you in the next video. Goodbye.